Hello everyone. So today we are going to solve another interesting problem number 2226 maximum candies allotted to a k children. And the problem says we have been given a zero indexed integer array candies. Each element in the candies denote a pile of candies size. Candies wise, you can divide each pile into any number of subpiles, but you cannot merge two piles together. Okay. And you have also been given an integer k. You should allocate piles of candies to k children such that each children get the same number of candies. Each child can be allocated candies from one pile of candies and some pile may go unused. Okay. So they want us to return the maximum number of candies each child can get. Okay. So we have been given one list of candies 5, 8, 6 and we have to distribute these piles of candy among three children, among k children, which is 3 over here, such that each children get maximum number of candies. And there is one more condition. What it says, each element in the array divide each pile into any numbers. You allocate pieces of candies k such that each child gets the same number of candies. Okay, each child can be allocated candies from only one pile and same pile can be. Okay, so in the problem we can divide candies 1 into 2 piles of 5 and 3, candies 2 into pile of size 5 and 1. Now we now have 5 piles of candies, blah blah blah. We can allocate 3 piles of size 2. Okay, so in total we have to distribute these candies among k children such that each children has equal number of candies and the children receive maximum number of candies. Each child receive maximum number of candies. True. And that's the only condition. So to solve this problem, what I can see from here is I can see that these candies and number of childrens and these candies are related somehow to each other. And what I can see that to find the number of children, what we can do is that from candies pile we divide by same number of candies that we choose to give, then we get the number of childrens. So we see that this number of childrens is inversely proportional to number of candies. So here from here we can see that this is some kind of this is one kind of monotonically decreasing function, right? And we will be starting from some left value and we will be starting from some right value, and we need to distribute these candies to our children. So let's me get it out. Okay, so here I am, and what I want to do is, there we go. So this is left and right, and here I am having number of childrens, which is some function of candies, and here I have the number of candies over here, and I'm looking for the target t is equals to 3, for which my number of candies is maximum, right? So candy maximum, this is on. So as per the problem, we have the minimum number of candies that we can have is L is equals to 0, and the maximum number of candies we can have from the candies pile, which is 8, right? And then what we'll do is we'll simply find the mid, which will be L plus R by 2. This will give us 8 plus 0 by 2 equals to 4, and when we have 4 candies, then for this mid value what we are doing is we are trying to distribute this among the number of students, so number of children that will get by dividing the pile with the candies pile with the same number of candies that we got. So here this is 6 by 4, the height was 8 by 4, and then we have 6 by 4. So what the integer value will get is 1 over here, 2 over here, plus 1. So that number of children are 4, and among 4 children we can distribute 4 candies from each pile. So I see that in the function I am here for k is equals to 4, right? I got the mid value, basically this mid was here, and for this I got the k is equals to 4. So, and I need to move over here, so in this direction. So what I can do is I can discard this region, and then I will be moving over here. So I will move my left towards the mid, and that will be 4. And for the next iteration we have r is equals to 8 that we have, and similarly we'll do the operation one more time. So this time we'll have the mid like this, our summation of candies divided by same number of candies, which is a function, which is a mid value that we calculate, and the mid value would be 4 plus 8 by 2. This will give me 6, and for 6 over here I am distributing 6 candies from each pile to the number of children to get the number of children. So this will give me, like, I have only 2 children to distribute. So now I'm on the lower end of the right side. So here I'm at over here. So this is for my new k is equals to 2. Thus this was the mid. So I know that I need to move my right towards the mid. I will discard, so somewhere between 4 and 2 I will reach my target 3 with the maximum number of candies. So I hope you have understood this algorithm. This algorithm is nothing but the binary search, and we are doing the binary search for a monotonically increasing a monotonically decreasing function, right? And we are looking for a maximum. So now without further ado, let me get into the coding part, where I would be solving this. Will I will be modeling this into our problem, into our code. So let me get over here, and I'm going to need my solution as well. So that is over here. So I need this on my side. So I don't need this now. I only need this portion that I have, because I need to see and write what I'm going to write. So I'm starting with the minimum value, and I'm starting with the maximum value for the bounds. So that is candies, and typical binary search until left is less than right. What we need to do is we need to find the mid. So the mid is L plus R plus 1. Since we are finding the maximum, we will be finding mid on the upper bound of the left and right. So now we'll do is we'll check our function, and if this function is greater than equals to k, then we need to move our L left boundary toward the mid. Otherwise, we need to move our right toward mid minus 1, and in the end, we'll return the left, because then when L is equals to R, will be returning that value. And now the only thing we need to define is this function of Candies. So this function gives us the number of children when we are distributing mid number of candies. And this, what we need to do is simply we are summing all the candies from the pile of candies. So for C in candies, I'm getting that sum from the mid, and I'm getting the lower bound. So that's why the quotient operator, floor division operator, or the quotient operator, you could say. So this is the algorithm that I have coded up, and let's run our solution and see how it performs for different edge cases. So it's saying, oh, silly of me, we can do this, or we can do something like this. So this has been accepted for case 1, for case 2 also. Now let's submit our solution and see how it performs for all the test cases. So it has been accepted and it's running good. So I hope you have understood the algorithm, binary search, and the time complexity for this is something special. So here, the time complexity is the O of uh, size, whatever is the size of candies. So this is my size of candies array, and I'm finding the uh, maximum value using the binary search. So that will give me the log of maximum value among the candidates, so log of m. So this, the time complexity would be O of n times log of n, where m is the maximum value from this pile of candies from the input array, whatever we are having at this time. So yeah, this is the solution for this problem. I hope you have liked my solution, and if you have any particular problem for me to solve, I would be happy to look into it. Till then, have a nice day, and I will see you tomorrow with some new algorithmic problem, where I would be showcasing how you can solve this problem using the algorithms from computer science and software engineering. Thank you and have a nice day.